Some systems need to be both high SIL and fail operational. To accomplish this, you can use a dual two-channel architecture, often called dual 2 of 2. The hardware pattern is that you have two pairs of cross-check CPUs. The first cross-check pair provides the primary functionality. Because that's a fail-silent pair, you can be sure that if a hardware fault occurs, that pair will shut down, initiating a failure to a hot standby 2 of 2 backup pair. So unlike the previous hot standby pattern that was 1 of 2, in this case you're sure that a fault will be detected if it's a hardware fault and that the failover will occur. There's still no software isolation, which means that all 4 CPUs have to be at the same SIL, which is the highest SIL of the system. The pro of this system is that it is the simplest high SIL availability pattern. It's suitable for life-critical applications, including both SIL 3 and SIL 4, so long as the software is developed to the appropriate SIL. And unlike the plain old 2 of 2 pair, which fails silent, this one fails operational because of the hot standby. There are clearly some cons to this architectural pattern. The first one is that, as we've seen before, all the software has to be promoted to the highest SIL in the system, which is potentially expensive software development. Ensuring that this is actually fail operational requires ensuring that the standby is ready to go at all times. This can be accomplished with periodic role reversal of the primary and the standby switching places, say once a day, but also requires periodic offline self-test in the form of proof testing to make sure there are no latent faults that are missed during normal operation. And there's the con that's fairly obvious of needing 4 CPUs to do the job of 1. But the reason this makes sense is that you have 2 different uses of redundancy in the same pattern. The 2 of 2 pattern is giving you fault detection, whereas the primary standby pattern is giving you fail operational on top of that. While this may seem like an exotic pattern, if you've ever ridden a train, there's a really good chance that this is the pattern used in the rail switches and the rail signaling equipment to make that train ride safe.